Hi everybody. Today I would like to talk about the differences between ionic and covalent bondings, which is really simple. It's not a big deal. It's not pretty much hard. And this idea is coming from Cambridge. And okay, let's go. So first, let's talk about their definitions. What's the definition of ionic compound? An ionic bonding. An ionic bonding is an ionic bond is a chemical bond between two dissimilars. So it's between a metal and a non-metal. And the process of ionic bonding occurs when the loss and the gain of electrons would happen between dissimilars, in which is related to the concept of oxidation and reduction, which is not related to this idea. So we understood that the ionic bonding is the transportation of the electrons. It's not the sharing of electrons. So what are covalent bondings? A covalent bond is a chemical bond, same as an ionic bond, between two non-metals. So it's not between dissimilars. It's not between a non-metal and a metal. It's between two non-metals. That involves the sharing of electrons between two similar atoms. So it's not the transportation. It's related to the concept of sharing of the electrons between two similar atoms. And as you know, the states at the room temperature, ionic bonds are usually solid, since usually they have a high melting and boiling points because of some reasons that we are going to talk about in the next slide. And covalent bonds, solid, liquid, or gas. It can be anything, since they have different types of melting and boiling points. Let's talk about their different properties. The polarity, as you know, in ionic bonding is high, and in covalent bonding is low. The shape of the molecule, so ionic bonding does not have a defined shape. It's a lattice structure. But a covalent bonding has a defined shape. For example, like diamond. Diamond is a giant covalent structure. And as you know, it's between 4 carbon atoms. Each carbon are going to be covalently bonded, chemically bonded, covalently bonded within 4 other carbons. And it is going to be a single covalent bond between them. Yeah. So they have a defined shape. And it's like a crystal. Like diamond, in this case, is like a crystal. So it has a defined shape. We cannot say that it doesn't have a defined shape. But ionic bonding, it's similar to a lattice structure. It doesn't have a defined shape. And related to their electrical conductivity, ionic bonding is high and covalent bonding none, except by graphite. Graphite is an exception. It's a giant covalent bonding, which it conducts electricity, and it's an exception. It's the only covalent compound which conducts electricity. And an example of ionic bonding, only in order to make you understand it easily, is NaCl or sodium chloride, and as you are knowing it as salt. And an example of covalent bonding is CO2. That's all the times per day we are using it a lot in the process of respiration. And it's a covalent bond, since the sharing of electrons is happening between the bonds, because these two oxygens are going to make a double covalent bond with the carbon. So that carbon is going to make a double covalent bond with each oxygen. So the carbon is going to share 2 of its electrons in its last shell. As you know, carbon has 4 electrons in its last shell, and it's really easy. It will share 2 of its electrons, half of its electrons, with 1 of the oxygens. And as you know, oxygen has 6 electrons. So 6 plus 2, those 2 electrons coming from carbon, is going to be added by those 6 electrons in the last shell of the oxygen, which is going to be equal to 8. So that oxygen, 1 of those oxygens, completed their electronic configuration. And now they are okay. And the other oxygen is exactly the same, and the other half and the other half electrons of carbon, which is going to be shared with the second oxygen, and exactly the same, they are going to complete their electronic configuration easily. And let's talk about their melting and boiling points. The melting and boiling point of an ionic compound is high, since there is a high force of attractions within the particles, the bonds, those chemical bonds, which we are completely saying it as a high intermolecular force. And it requires a lot of energy to break the bonds, since as you know, there are some delocalized electrons within the ionic compounds, since there are a nonmetal and a metal that are going to occur on those bondings. So there are some delocalized electrons that they are moving and orbiting around within and around the particles, around the elements occurring on that specific compound. So they have a higher intermolecular force, and that's why it requires a lot of energy to overcome and break the bonds. So it has a high melting and boiling point. And as you know, this fact that the elements, all the elements, they did not, on the periodic table, they did not want to lose their complete electronic configuration. Or if they are not in group number 8, that means they did not have a complete electronic configuration while they are neutral. So they are going to be placed in an ionic bonding or in a covalent bonding, depends on their properties. So they are going to gain, or they are going to lose, or they are going to be shared, or they are going to share their electrons in order to complete their electronic configuration. So it's really easy, it's really simple. And the melting and boiling point of covalent compound is usually low, since the intermolecular force is not that much high to require a lot of energy to overcome. So we can break the bonds of a simple covalent structure much easier than those ionic compounds. But except by some giant covalent structures, since there are a lot of elements that they are chemically bonded together in order to make a strong covalent bond, those they have a high melting and boiling point. For example, diamond, for example, graphite. So because there are a lot of carbon atoms that they are being chemically bonded within each other, so it's going to be really high and it will be really hard to overcome. And so therefore they have a high melting and boiling point. And so the simple covalent compounds, let's say most of the covalent compounds, they have a low melting and boiling point, since the intermolecular force is not that much high to make it hard to require a lot of energy to overcome and break the bonds. Because it's between two nonmetals and there is no electrical conductivity, so there is no delocalized electron within the elements. That's all for today. I hope you a great day and see you in our next video.